Hello, my name is Peter Ross, and I'm here to talk about the clean technology of geothermal heat pumps. So what is a geothermal heat pump? Well, a geothermal or ground source heat pump takes advantage of the fact that 5 feet below ground, the Earth consistently stays between 45 and 70 degrees Fahrenheit. So in a typical closed loop design, as illustrated on the slide, an above ground heat pump moves a fluid mixture, a non-toxic antifreeze solution, through a circular underground pipe. In the winter, the earth warms the fluid as it passes underground, and then this heated fluid returns to the building where it is used for space heating. In the summer, as illustrated on the right, it operates in reverse, removing heat from the building and transferring it to the now cooler ground. It acts as a heat sink. And depending on the design, heat pumps can also supply a building's hot water needs. Heat pumps exist all over the United States in all 50 states, and they are not limited by geography, weather, or climate. Geothermal heat pumps are generally deployed on a distributed basis. And by that I mean residential or commercial property owners install these heating systems in their own buildings. Although there are certainly positive externalities and environmental effects, the benefits of lower energy bills, resiliency, and safety, as well as the costs of installation and maintenance, accrue largely to the individual building owners. Now, there have been some experiments in deploying these systems on a decentralized community-wide level. The best example of this is at Ball State University, which currently has the largest geothermal heat pump system in the United States. And when you deploy this technology at scale, at a larger scale, you can achieve advantages in aggregated loads, economies of scale, and increased efficiency of equipment. So what are the environmental benefits? First and foremost, you're replacing fossil fuel heating sources. That includes natural gas and fuel oil. Fuel oil is dirtier and more expensive than natural gas, and as such is a prime target for geothermal heat pump installers and state governments looking to promote geothermal systems. But whether it's natural gas or fuel oil, both eliminate carbon monoxide and risk of gas leaks and particulate emissions and other pollutions associated with fossil fuel generation. And when you reduce or replace fossil fuel with electric heating, efficient electric heating of a geothermal system, you also reduce greenhouse gas emissions. And as you can see from this chart, which shows the annual GHG emissions from different heating technologies, whether it's oil, propane, or natural gas, installing a geothermal electric heating system results in reduced GHG emissions. And as the grid gets cleaner, as you can see on the 3 bars on the right, the reduction in emissions gets even greater. What's more, in addition to replacing fossil fuels, you're also using less electricity, and this is because geothermal heat pumps are really efficient. Because they take advantage of the constant temperature in the ground, they need less electricity to achieve the same heating result. And this chart essentially crunches the numbers for a 100,000 square foot commercial office building, and that has a geothermal system versus one that's powered mainly by natural gas. And as you can see, the geothermal system results in less energy usage as well as fewer greenhouse gas emissions. Moreover, geothermal heat pumps are more efficient than air source heat pumps or other types of heat pumps that are electric. And as you can see from the last line of this chart, the average energy savings, the geothermal results in more energy savings than either a mini split or an air source heat pump. Additionally, there are reliance benefits. And so when you're not reliant on fossil fuels, you also are not reliant on not subject to fuel shortages or price spikes. And this technology pairs well with distributed renewable energy, such as solar photovoltaic panels on your roof. And if you put combined solar PV and a geothermal heat pump system, you can have a really resilient home that's not dependent on or that's less dependent on grid-provided energy. Additionally, because many parts of the geothermal system are underground, they are resilient to storms and other events and damages that can happen above ground. So this is a New York Times article from 2012, which noted that Hurricane Sandy, which unearthed fuel tanks and ravaged cooling towers and battered air conditioners, spurred policymakers and advocates to reconsider geothermal systems. And on the right is an example of a geothermal energy system at the Brooklyn Children's Museum that was installed in 2007. So, if this technology is so great, why doesn't everyone have it? Well, the main reason is cost. Geothermal systems have a higher upfront cost than their competitors, although those costs have come down in recent years. Typically, the cost for a typical home is around $20,000 to $25,000 to install. It's around double the cost of a conventional heating and cooling system. But you also get reduced utility bills, and so over time the system will pay for itself. Government subsidies have helped reduce the cost of installing a geothermal heat pump system. You get a 30% federal tax credit, which reduces over the next few years, and that stacks on top of any state subsidy already in place. So in New York, a geothermal system that costs $26,000 could be eligible for a $6,000 rebate from NYSERDA under their ground source heat pump rebate system. And additionally, from that $20,000, you get 30% of that is subject to a federal tax credit. So the total cost would be around $14,000, and that's around a 47% reduction from the sticker price. And although it's still expensive than some conventional heating systems, it's more competitive than it otherwise would be. So that's the end. That's my introduction to this technology. The benefits, how it's deployed, the regulatory framework that governs it. A key factor going forward will be if a combination of cost reductions on the commercial side and subsidies on the government side can spur even greater adoption of this clean technology in the Northeast and throughout the nation. Thank you.